This is Chapter 8 of the Introduction to Computing and Programming in Python, a multimedia approach, the fourth edition, modifying samples in a range. So the chapter objectives for Chapter 8 are to splice sounds together to make sound compositions, to reverse sounds, to mirror sounds. The computer science goals for this chapter are to iterate an index variable for an of sample arrays across a range, to use comments in programs to understand why, to identify some algorithms that cross media boundaries, and to describe and use scopes more carefully. So, knowing where we are in the sound. More complex operations require us to know where we are in the sound, which sample, not just process all the samples exactly the same. For example, reversing a sound. It's just like copying, like we did with the pixels. Changing the frequency of a sound, using sampling, like we did with pixels, or splicing sounds. So using for to count with a range. So in the example here, we can see that we print out the range 1 through 3. So it's going to print 1 and 2. We can print the range 3 to 1. That's not going to print anything because that's not really a valid range. What if we do negative 1 to 5? It's going to do negative 1, 0, 1, 2, 3, and 4. And then if we do 1 to 100, it does the same. So increasing the volume by sample index. So here we have a function. We define it, def. We define it, the function name as increase volume by range. It takes one parameter, which is a sound variable. And then we have a for loop that says for the sample number in the range from 0 to, we have a function get length of sound. So it's going to be the range of starting at 0 to the entire length of the sound. That was passed in. And we have the value equals get sample value at. So we're iterating through, or we're going through every um, object inside the sound object, and we're getting the value at each index. And then what we're going to do is we're going to set the sample value um, at each index to what it was of the sound, and then we're going to modify the value just a little bit. And then if you look at the bottom, what we have up there is really the same as what's below. So we have increased volume. So in the top one, we say for whatever in range. The other one we have for sample in get samples. You see that? So it does the exact same thing. We double the sound volume, right? Because we do value times 2. Um, but one uses a range and one just uses the objects themselves. So modify different sound sections. The index lets us modify parts of the sound now. For example, here we increase the volume in the first half and then decrease it in the second half. So this looks a little complicated, but what it really says is that, let's break this apart. So what we can see is, we say define increase and decrease, right? So it passes a sound variable. Length equals the get length of sound. So get length method, passed by the sound object, returns the length of the sound object. So then we say for index in range, and then we have 0 to length divided by 2, right? So length divided by 2 obviously is the first half, right? So we go through the for loop. We do all our operations. We multiply by 2. And then after this for loop's done, we have another for loop that says for the sample index in range. And then we have length divided by 2 comma length. Right? So then this is the other half of the length or of the sound that we didn't touch yet. And then what it does is it decreases the sound. It's kind of cut off on the bottom, but we can actually see that it's multiplying by a smaller number, and it's actually decreasing the volume of the sound. So the first half does 0 to the halfway mark, the midpoint, and then the second part does the midpoint through the end of the file itself. Array references. So square brackets as you can see in that, as you can see here, are standard notation for arrays or lists. To access a single array element at position index, we use array and then square bracket index, right? So if we set, for example, my array equals the range from 0 to 100, right? That's going to populate the array variable, sorry, the my array variable with the numbers 0 through 100. So say we wanted to get a certain index in that array. So if I want to index 0, I can say print my array, so that's the variable that we had previously, and then I can use the square bracket notation to get the element at the position that I pass in there. So if I want the position 0, I'm going to get 0. If I want the position at 1, I'm going to get 1. They happen to be returning the same thing only because the range is from 0 to 100. If I were to do 100 to 200 and I got the first and I got array at element the sorry if I got the index at element position 0, I would get 100 in that example instead of 0. So, and then as you can see in the for the last one, my array at the element at position at index 99 returns 99 as well. So splicing sounds. Splicing gets its name from literally cutting and pasting pieces of magnetic tape together. Doing it digitally is easy in principle, but painstaking. The easiest kind of splicing is when the component sounds are in separate files. All we need to do is copy each sound in order into a target sound. Here is a recipe that creates the start of a sentence. Guzdial is. You may complete the sentence. So here's we can see here's an example called merge. So what it does is it sets the variable guzdial, which I believe is the author of this book. It says guzdial equals make sound, get media path, guzdial.wave. So we take a wave file, we make it to a sound object, and then we set it to the variable guzdial. Is sound um, we do the same thing for is sound, which is a variable, and it actually uses the is.wave file. So in the first um, sound, it says the word guzdial. In the second sound, which is sound, it actually says the word is. So if we play the guzdial variable, it's going to say guzdial. If we play the is sound variable, it's going to say is. So then we say there's a 3 seconds of silence wave file. And then let's skip down a little bit. So we have target equals 3 seconds of silence, for source and range, the guzdial. So what you can actually see is happening is that we're actually going through each sound file. So we're going through guzdial, right? And we're actually setting the sample value to the target, right? Target is 3 seconds of silence wave file. So what we're actually doing is combining the guzdial and the is to make some sound that's put together. And then we can see we down here we do the same thing. We go through is sound and we update target as well. Cool. And then we normalize the target, we play the target, and then we actually return the target. So, uh, what additional functions must be in the file for that program to work? Normalize, play, get media path, or maximize. So we can see that there's normalize right in there, right? Play, right? So, but play's built. We know that play's built in. Let's see if actually normalize is built in. So we're gonna switch over to JES for a second. We're gonna go to JES functions. We're gonna go to sound, and we look for the word normalize. Not seeing it there. So normalize needs to actually be implemented for that program to work, right? So how it works, it creates sound objects for the words guzdial is and the target silence. Set the target silence index to 0, then let each loop increment index and end the loop by leaving the index at the next empty sample ready for the next loop. The first loop copies in guzdial, the second one creates 0.1 seconds of silence, the third loop copies is in the target, and then we normalize the sound to make it a little bit louder. Splicing words into speech. Say we want to splice pieces of a speech together. We find where the endpoints of words are. We copy the samples into the right places to make the words come out as we want them. And we can also change the volume of the words as we move them to increase and decrease emphasis and make the words sound more natural. Finding the word endpoints. Using media tools, we can play before and after cursor. We can figure out the index numbers where each word ends. We want to splice a copy of the word united after we, the, so that it says, we, the United People of the United States. So, based on going through the media tools, playing with that, and looking at each, we can get the index itself by playing it and going through it. So then we can actually make this similar table where it says, we, the people of the United States, and we can see the index at each location. Right. Now it's all about copying. So we have to keep track of the source and target indices. So destination sample, we can see in this down here, where the incoming sound should start. So we go through and we actually can input the destination. We can put the source to the destination. So here's the entire splicing. You can take this as an example. You might not, well, I'm assuming you don't have the preamble, so you might have to do something similar for this example. But just go ahead and get familiar with each of the functions. Try to understand what they're actually doing. You'll notice that there's comments in here. The comments will help you understand what each line's actually doing if it's not super straightforward. Especially since in this example they use a lot of see, you can see a lot of numbers that are the ranges. Well, the ranges are defined by like people, for example, or united or we the. So um, this will be a good example for you to get familiar with more of the sound file, the sound built-in functions that JES offers. So then we can say we want to know what's going on here, even though we kind of went over it briefly. We'll wrap it up one more time. So first we set up a source and a target. Next we copy United, the sample 33414 to it's the range of 33414 to 40052. And then we want to copy it after we the, which is sample 17408. That means we do some weird math, and then I don't know where the people starts. So then we copy people 17402 and then to 26726 immediately afterwards. Finally, we insert a little space just to give it a slight break, and then we put it all together. We're gonna skip this example because it's still referring to that. General clip function. We can simplify those splicing functions if we had a general clip method that took a start and end index and returned a new sound clip. So here's a little bit of an optimization, right? Um, this clip function that is defined here will actually allows you to give a source, give the start index and the end index, and it'll actually return on the very bottom. It actually returns that sound clip that you actually wanted. So it could actually clean up this quite a bit. Um, so that you're not repeating and repeating this functionality. You can just define a method called clip, and use that going forward. And that's really the main point of programming in general, right? Because programmers are lazy, right? And we want to simplify our day-to-day tasks. If there's something that's repetitive, we want to make it a function. If there's something that's um, if there's something that you see that, oh, I'm going to use this a lot, or oh, this will help clean up my code, make it more understandable, make it more readable, then go ahead and for sure make it a function. So the general copy function, we can also simplify splicing if we had a general copy method that took a source and target sounds and copied the source into the target, starting in a specified target location. So here we can see this is another way to merge uh, the source and the targets together. So then we can actually, in this case now, we can see that the preamble function that we had previously, which was right here, a lot of for loops going on. It's a little bit of craziness. We can actually see that it can be simplified as to just here, right? We can see our copy methods. We can see our clip methods. Um, notice the variable names, and they all make sense, right? United equals clip, right? And the clip right there is going to return the word united, right? That makes sense because your variable names should be straightforward. They should be easy to understand, um, especially if you were to stop working on your program halfway through or something, and another programmer had to start, they would be totally lost if you named you instead of saying United, you said uh, index 33414, right? That wouldn't make any sense. So keeping understandable variable names is super important. So what if we wanted to increase or decrease the volume of an inserted word? Simple. Multiply each sample by something as it's pulled from the source. Could we do something like slowly increase volume or normalize the sound? Sure. Just like we've done in the past programs, but instead of working across all samples, we work across only the samples in that sound. Reversing sounds. We can also modify sounds by reversing them. So here's an example: target reverse. Um, we grab a sound. Sorry, we grab a. We have one parameter called source as our input. Target variable equals make an empty sound of the length of the source. So we're going to make an empty sound file the exact same size as what we pass in. And then our source index is the length of source minus 1, right? So we're going to start at the very end of the object. And then we're actually going to work our way backwards, right? So we can actually see if you look inside the for loop, the very last line inside the for loop body, we say source index equals source index minus 1. So we're decreasing as we iterate through the range because we want to move backwards within the source file, right? And then we'll copy this. We'll totally reverse the sound. So you can see in the as they explore the sound file in the bottom, you can see that it's a big chunk of sound. If we see here, it's a big chunk of sound followed by a little bit of a space and then a smaller chunk. And then here we can see the little bit of a space, kind of, right? Which is it's totally reversed, right? There's the smaller chunk, there's the bigger chunk. So what does makes empty song take as an input? So based on the last program, what do you think make empty song takes as input? Number of samples, number of bytes, number of seconds, or a song to copy? So let's go back for a second. Um, I believe this is actually in a typo in the PowerPoint. I believe this should say make empty sound. All right, so what would make empty sound take? If we look at back here, it's the length of the source that you pass in. So it's the length of the sound object. So if it's the length of the sound object, right, it should be the number of samples. But let's just check JES to verify. So we're going to go to sound and we're going to say make empty sound. And what does it take in? Yep, it takes the number of samples in the sound. Cool. So mirroring. We can mirror sounds in exactly the same way we mirrored pictures. So we see here we're defining a function called mirror sound, takes in an input of sound. The length equals get length of sound, so we're gonna get the how long it is. The mirror point equals length divided by 2, so that's the midpoint. And then we say for index in range, so for the first half of the sound, we say left equals get the sample object at the index, right equals get the sample object at the index, the length minus the index minus 1, and then the value equals get sample at left. Then we set the right, it's a little bit of a confusing thing, we set value of right uh, to what the value was at the left. So then based on that, we're mirroring these two objects together. From the halfway point, we're doubling. So from the beginning, from the origin point or the 0 to the midpoint, we're copying from the midpoint to the end. Um, so as you can see in the bottom, this is what we would get out at the very end. Functions and scope defined. Let's call the variable that represents the input a parameter variable. Key idea. The parameter variable in a function has nothing to do with any variable, even with the same name, in the command area or anywhere else. Parameter variables are local to the function. So that we say that it's in the function's scope. So let's think this through. So if we want to print ABC here, it says hello, goodbye, Mark. So this is just an example, but what this previous page was trying to say is that if we see the this a right here, so it says define or the definition of function one, and then it's a parameter a. It's saying that if we were to print a out here, it's not the same as the a in here. right? So what this function is going to do, it's going to print A. Whatever we pass in, it's going to print A. Then A equals 12. Then C equals George. Then it's going to print AC. Okay, does that make sense? So here we print A, B, and C. So A is hello, B is goodbye, and C is Mark. So if we pass fun2 and we pass in B, we would expect that because we're passing in B, it's gonna right here, right? So if we pass in B, it's gonna print out B. So sorry, if we pass in B, which is goodbye, it's gonna print out goodbye. It's gonna set B equal to 13, and then it's gonna print B and C, right? B is 13, C is Mark. Then if we print A, B, and C again, hello, goodbye, Mark. Values are copied into parameters. When a function is called, the input values are copied into the parameter variables. Changing the parameter variables can't change the input variables. So this is saying that if we were to pass in, um, say we pass in something to function 2 right here, and then we wanted to, so b equals 13, it's not actually changing the b here, right? Even though we're saying b equals 13 inside the function, well, b outside the function in this command area is still the word goodbye, right? We're not changing it. So this is saying that um, the scope of b is just inside here. It's not going to leave. It's not going to leave there. So changing the parameter variable can't change the input variable. All variables that are local disappear at the end of the function. We can't reference variables external to the function if we don't have a local variable with the same name. So parameters as objects. Slightly different when you pass an object like sound or picture. You still can't change the original variable, but you've passed in the object and you can change the object. Right? So P equals make picture, pick a file, and then we say increase red P. Increase red can't change the variable P, but it can apply functions and methods to change the picture that P references. That object or that picture, the object, is the value that we passed into the function. So that's all that chapter 8 includes. A couple different things that we went over. So definitely take some of these examples. I know you can't do all the sound ones exactly how they were, but just practice the overall general idea of splicing, of mirroring different sound files. You have the Antelope file from a couple weeks ago, so definitely go over that one. And yeah, take these as examples and try them out and see how they work. And if you have any questions, as always, shoot me an email and let me know. Thanks, guys.